All right, fine. Now, doing this one, we can't solve for y, but one way I can do it myself, another way. I could multiply by x plus y. You understand what I'm saying? Yeah. To have it in this form, where there is no denominator. Or I can keep it as is. Either way, it's fine. But I would want to multiply it because it's going to make my life a little bit easier. When it's division, I'm going to have to do the derivative of the bottom and a lot of the top. Or I can do it as it is. Because if people say, he's running away from it when it's like this, that's when I really want to do it. You know what I'm saying? All right, so let me kind of do it. Let me do it as is, the way it is. Let me not change it here. But it will look complicated to you. That's where the problem is. The problem, it will kind of look complicated to you. All right, so here I go. All right, we derive the left-hand side. So the left-hand side, it's just going to be 2x times by the derivative of the base, dx, which is 1. No problem, equals 2. The other side, derive the top. When I derive the top, when I derive the x is 1. When I derive minus y, it's going to be minus, it's minus the derivative of that. It's dy all over dx. Now the problem is when you write dy over dx, it looks complicated for you. I would rather do this to make it easy and say it's y prime. So now you know what y prime is. We good, right? And then multiply by the bottom. The bottom is going to be x plus y. Then we minus the top times by the derivative of the bottom. It's going to be 1 plus y prime. It's going to be 1 plus y prime. That's what it is. There we go. And then we need to divide. You see, I ran away from dy over dx now. I changed the gear. The bottom one, it's now going to be x plus y all squared. So the guy that I want to solve for, I'm writing him in yellow. I want that guy in yellow to be the subject of the formula. We good, right? So I just multiply both sides by the denominator. So let's take it one step at a time. So we got 2x into x, and then plus the y, close the bracket, all squared, equals to the other side. I can multiply into, when I multiply into, oh my, let's multiply into, if I use the 1, I've got x plus y. If I use the y prime, I'm going to have minus x y prime, and then plus the y prime. It's not y squared, the other one is a thing. And then I need to minus this. Before I can minus, I'm going to multiply by 1, is going to be x, then we say minus the x. 1 will times the y is going to be minus y, the sign changes, is going to be plus the y. Then I'm working with the prime. Y prime times x, so it's going to be negative x y prime. Then plus y prime. Y times y prime. That's what I mean. That's what I've got. Are we together on that one? All right. It looks like to me that one and that one will cancel. Is that so? Is there anything that cancels there? Do you see anything cancelling also? No. All right, so I'm dealing with the left-hand side. Left-hand side, I've got y and y, so I've got 2y, correct? That means that and that are gone. All right. What else have I got? I've got this one, minus xy prime minus xy prime. So it's going to be minus 2xy prime. How about the other one? The y prime. So it's two of those one. So it's going to be plus 2y and then times by the y prime. So the blue 2y must go to the other side. So which means in the next step I should be writing 2x, that was supposed to be on the left, x plus y, close bracket, all squared, minus 2y, then equals to, out of this I pull out a common vector. So I'm going to parenthesize that. So I'm going to have minus 2x plus the 2y. And then outside the bracket is going to be y prime. So what's in the green box must go and divide the other side. Then I would have my dy over dx done. Correct? Yeah, so I'm going to write it as y prime now becomes 2x into x plus y all squared minus the 2y and then all over that white portion, which is minus 2x and then plus the 2y. Maybe while it might cancel. So that will be the thing. I think now you got